In this video, we will solve 5 problems in engineering economics under the topic Annuity. And for our first problem, the cost of a border fence is 150 million pesos per mile. If the life of such a fence is assumed to be 10 years, what is the equivalent annual cost of a 10-mile long fence at an interest rate of 10% per year? So in this problem, we are going to solve for the equivalent annual cost for a fence that is 150 million pesos per mile. So what are the given here? We have the cost of the border fence. So P, the principal, is equal to 150 million pesos per mile times, that is 10 miles. So that is for a total of 150 times 10. So let's just say 150 M. And then we have here the number of years equals 10 years. And I, interest rate, equals 10%. So what is now the equivalent annual cost? So using the present worth of annuity, this is 150 M equals the equivalent annual cost times 1 plus 0.1 raised to 10 all over 1 plus 0.1 raised to 10 times 0.1. So what's now the equivalent annual cost? So 1500 times 10 raised to 6 alpha equals alpha x times 1.1 raised to 10 minus 1 and 1.1 raised to 10 times 0.1. So shift solve here, that is 244 million. So this 244 million 118,092.32 pesos. So that's the equivalent annual cost. That's number 1. Let's go to the problem number 2. A masonry products company wants to have 30 million pesos on hand before it invests in new conveyors, trucks, and other equipment. If the company sets aside 4 million pesos per year in an account that increases in value at a rate of 15% per year, how many years will it be before the company can purchase the equipment? So it's asking for the number of years n. So what is the given here? So we have here the 30 million pesos. And the question here is, what is that 30 million pesos? Is that future or present? So the company wants to have 30 million pesos on hand before it invests in new conveyor trucks and other equipment. And it says here in the problem, the company sets aside 4 million pesos per year. So what is 30 million pesos? So it's obvious that we have an annual savings of 4 million pesos per year. In order to have 30 million pesos. So the 30 million pesos here is actually a future worth 30 million. So we can now solve for the number of n given I is equal to 15%. So that will be 30 million equals the annuity of 4 million, 1 plus 0.15 raised to the power of n minus 1. So it's missing here n. Then since we are this is future worth, therefore we will use the formula for future worth of annuity. So what is the value now here? So what we will do is we will just leave it here. Well, let's try the shift solve. So if you're going to use the shift solve, hopefully it will give you the answer, but sometimes it does not. 1.15 raised to alpha x minus 1 over 0.15 shift solve. So from our shift solve here, it says that x is equal to 5.39 years. So this 5.39 years, that will be equivalent to or approximately equal to 6 years. Okay. Now what if in your calculator it did not give you this value, instead it gave you other values? What will you do? Now we can just use the long method. So our long method will be 30. So cancel m. We'll cancel the m already. Or well, for clarity, we can just leave it like that. 30 million times 0.15 all over 4 million, and then we have the plus 1. So that will be 2.125. So 2.125 equals 1.15 raised to n. And what will happen here is that we will use the logarithms. 2.125. Then bring down the exponent, n log of 1.15. So the value of n now here becomes log of 2.125 over log of 1.15. So that is 5.39. So same. Okay, so that's number 2. So the company will have 5.39 years or approximately 6 years before it can purchase the equipment. Now let's go to the problem number 3. A man wants to deposit money for 4 consecutive years starting 3 years from now, so he can withdraw 2,750,000 pesos 12 years from now. Assume the interest rate is 8% per year. What is the annual deposit? So it's asking for the value of A. So what is the annual deposit A? So let's draw the diagram here, cash flow diagram. So this is our year 0. This is 1, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it says here, if a man wants to deposit money for 4 consecutive years starting 3 years from now. So here is the consecutive payment, 4 consecutive payments starting 3 years from now. So what's the value of A? So this is A question mark. And the target here is on the 12th year. So this is the target. So he can withdraw how much? So he can withdraw this amount, 2,750,000. So what will we do here? So from the year 0 of this annuity, so the year 0 of this annuity is at the 2nd year. So year 0 here, then we'll have line here up to the 6th year. So what is the number of annuity? So there are 4 annuities here, number of annuity. And then from here, let's name this as F1. So from here, we will use compound interest up to the 12th year. So this now becomes F2. So what is now, what's going to happen here is that we need to find the value of F1. So for F1, using the future worth of annuity, so F1 is equal to the A. So how many percent? 8%. 1.08 raised to how many? Annuity, they are 4 minus 1 all over 0.08. So remember, this is future worth of annuity. So this is F1. Minus 1 over 0.08. So this is 4.0618. 4.50618. So using this information for FA, we will now use the compound interest for here. And for how many number of years? How many number of years starting from 6 up to 12? So that will be 6 years. So that will be 0 here. This is the year 0. 1, 2, 3, 4, 5, 6. So there are 6 years up to F2. So solving using the compound interest, FP1 plus I raised to n. Our F here is F2. The P here is F1. So our F2 is 2,750,000. So this is the target withdrawal, equals the P here, which is F1. So that will be 4.50618 times 1 plus 0.08 raised to 6. So what's now the value of A? So So 2,750,000 all over 4.5061 times 1.08 raised to 6. So that is 384,582.34. So that's number 3. Now let's go to the problem number 4. A municipality has arranged to borrow 30 million pesos in order to implement several public projects, flood control, school security, etc. The interest rate will be 3% per year, payable at the end of each year. This 30 million pesos debt will be retired by making principal payments of 5 million at the end of each year. The Board of Supervisors is concerned that it will take too long to pay off this debt. How many years will it take to retire this 30 million peso debt and its associated interest payments? Okay. So this 30 million debt is to be paid in how many years? So we have here the 30 million is the principal amount. So P is the 30 million pesos, whereas the 5 million pesos is being paid at the end of each year. So annual payment here is 5 million pesos. Now it's asking for how many years to retire this 30 million debt and its associated payments. So using our present worth of annuity formula, so this is 30 million for the P. For the A, that is 5 million. So 1 plus I, our I here is 3%. How many number of payments? So N minus 1 all over 1 plus 0.03 raised to N times 0.03. So what's the value of N? So that will be 30 million. Alpha equals 5 million times 1.03 raised to alpha x minus 1 all over 1.03 raised to alpha x times 0.03. Shift solve. We have here 6.71. N is 6.71, or that is 7 years. So that's for number 4. And the last one for this video, problem number 5. what amount of money a person must deposit 3 years from now in order to withdraw 10,000 pesos per year for 10 years, beginning 15 years from now at an interest rate of 10% per year. So, what amount of money must a person deposit 3 years from now in order to withdraw 10,000 per year for 10 years beginning 15 years from now? So that's a total of 25. So let's draw a cash flow diagram. So that's actually 25 years. So if we do some cut, so 0, 1, 2, 3, 4. Then we can use some cut here, and we will continue at 14, 15. So says here what amount of money a person must deposit 3 years from now. So it's asking here is the value of P. In order to withdraw 10,000 per year for 10 years beginning 15 years from now. So beginning 15 years, here is the beginning of 15 years. So if we continue here, so 16, 17, 18, 19, 20. Or we can break it again. Then let's continue here at say 21 or 24, 25. Okay. So for the payment of for 10 years, he paid for 10K. Now this is the year 0 of this annuity. So we need to find the value of P. What amount of money a person must deposit 3 years from now. So we have here so the number of annuity here is 10. And then this is the P1. And from this P1, we will proceed to here. And let's name that as P2, or that is actually the P. And for how many years? Number of years here. That will be 14 minus 3. That will be 11 years. So this is M, 10, and 11. Okay. So P1, using present worth of annuity, we have here 10,000. 1 plus 10% raised to number of annuity is 10 minus 1 all over 1 plus 0.1 raised to 10 times 0.1. So P1 is now equal to 10,000 times 1.1 raised to 10 minus 1 all over 1.1 raised to 10 times 0.1. So 61,445.67. So 61,445.67. Now from here, from this P1 here, we will now proceed to P. So for the solution of this, we will solve using the compound interest formula F. So F is equal to P1 plus I raised to N. So P is equal to the future worth of annuity. So if we're talking about this stage, this becomes the F1 becomes and the F is now the P1 equals P1 plus I raised to N. Therefore, our principal amount here is equal to P1 over the formula 1 plus I raised to N. So P1 is 61,445.67 divided by 1 plus 0.1 raised to how many years? We have there 11. So P is equal to 61,445.67 over 1.1 raised to 11. So 21,536. So 21,536.33. So that's the answer for problem number 5. Okay, so that's all for this video.